Now to clean this up, because I was talking about I want to repeat this multiple times. So I could array the final object like a more traditional method. And if you go to transform, you'll see that there is the ability to have a linear array. So this command can take any geometry, and let's make it in the y dimension. So I'm going to use a unit y. And I think it automatically has a count of 10, which is this input here. So I can do that. But that's still thinking about this process using traditional modeling constraints. This is probably how I would build it if I had to do it manually. I would never want to build one square and then repeat the whole process all over again every single time. But because this is with code, I can repeat this multiple times very easily. In fact, we're going to get our first taste of lists. So because this whole object here is based on base point, all I have to do is plug in multiple base points into this script and it will repeat itself multiple times. So to streamline this, first I want to simplify and organize my script a little bit. Notice how this base point goes into multiple spots. And if I were to update this, I would have to override the multiple wires. So let's clean this up using a relay. So a relay is just a little pass-through container that we can use to store things. Now if I right-click on the relay, I can rename it, say base point. And then this can be used to plug into multiple things. Alternatively, if I double-click on any wire, it will create a nice little relay on that wire. So this is really used for when you have lots of wires like this, you're able to very quickly override values. So for example, rather than having this go into two things, I can do something like that and then rename this to width. And what's nice about this is if I wanted to override that width, I could simply override a single location rather than having to override both spots at once. I strongly encourage you to use relays to control your inputs and to label them effectively. So let's say I have this relay and I want to plug in multiple, I want to update all these wires. There's a nice little trick. If you hold Control and Shift, I'm able to select all the wires at once. So now I can take what was that one output and now they're all connected. So again, that's Control and Shift. You can change the input of multiple wires at once. Okay, so now that this is a little, let's update the width. So this is nice. I have one object. Now let's try to pipe in multiple points at once. So there's several ways of doing this. One option would be to, say, copy this point. If I were to adjust let's change the y coordinate. If I hold Shift, I could plug in multiple points. Now notice as I adjust this, what's happening here, notice the wires changed from a thin wire to a thicker wire. Let's use a panel to look at what's happening. The thin wire means there's a single object, whereas the thick wire means there are multiple objects. And notice here is the list index. So this list means I have multiple objects. So item 0, item 1, we'll get more into lists later. And there's actually a powerful way of building this. So let's, rather than manually, if I wanted to say create a third one, I'd have to repeat this a second time. No, I don't want to do that. Let's instead not notice how we're repeating a lot of things here. In fact, if I want to create multiple points, I could simply add multiple y values and have this command generate multiple points for me. So what I'm going to do is use a range command. So this says give me a domain. So in this case I'm going to create a range of numbers between 0 and 1 and I'm going to have 10 objects. So here it gives me values between 0 and 1. So if I were to plug this into the y coordinate, notice I get a whole bunch of little squares. And that's because this point is no longer creating a single object, but it's creating multiple points. So I'm going to use a series of panels to give you a brief introduction to lists and how components operate multiple times. So up until now, every component did one thing and it did it once. But what I'm showing you here is that the components are set up to iterate or to operate multiple times. So let's look at all of the different inputs that we have. So I have that under my X, but then under the Y, I have a big long list of values. And actually, let's use this panel. And the Z command, I have a single value. And let's take a closer look at what's happening here. So you can think that this point command, it begins by going through item 0. So it says, all right, X is 0. Actually, let's label this. If you right-click on a panel at the top, you can change its name. I think this will help clarify what it is that we're doing. All right, so this here is the X, Y, and Z coordinates, and then the final point coming out. So this command here begins by looking at item 0. So it goes 0, 0, 0, creates a point, 0, 0, 0. Then it goes to the second item. Now there's only one object put into X, so it's going to repeat that. So it goes 0, 0.1, 0. You see that's what happens. So it will continue down this list until it runs out of things, and then it stops. So as you see, this single component is now creating 11 different points. And that information gets piped through the exact same script we had. So now this move command doesn't just move one object, it moves 11. And all of those combine to create not just one surface, but 11 objects. So rather than taking a single final surface and then moving it or copying it 10 or 11 times, I actually went to the front of my script and updated this component, and it then repeated the command repeated my script many times. So this is kind of a different way of modeling things, and it gives you some really powerful capabilities. Let me delete these for a second, and I'll show you what I mean. So if right here I'm changing my the Y coordinate, which is building multiple points, which builds multiple surfaces, I can also update the width. So right now they all have the exact same width, right? I can increase it or decrease it. Well, what happens if I pipe in not a single width, but multiple widths? So if I simply take this range and override the width, you'll see now for every single time that this the move command happens, in this case the vector, I'm now piping in one different length vector for every single point that I have. So the first point, it's going to move it 0, which is why no square showed up. The second one, it's going to move it very slightly until by the end it's getting a larger value. In this case, it's following the exact same logic as my base point. So this is starting to show you how you can create some very complicated forms simply by manipulating the same basic script. And I'm going to show you a little example of how you can even use math to now start to drive geometry. So here we have our widths are following this number, right? This is, actually, let's look at the width directly. So that's my width, and this is my Y coordinate. I'm going to label these so that we can see it more clearly. I should spell it right. Okay, and I'll call this my width. And what I'm doing is I am setting the width to be exactly the same as the Y coordinate. You can see these are the same. Well, what if I wanted the width to be a function of the Y coordinate? Well, as I mentioned before, we have the ability to manipulate data in Grasshopper. So let's take that number and let's write a very simple function. And really it doesn't matter what we do here, but I'm just going to come up with something so that it looks cool. So if I take this Y coordinate, and let's say I'm going to actually just use this number slider. Let's say I subtract that. Let's take a look at what it is that we're making. So now you see I have negative values up to positive values. I'm going to use an absolute value command. So all this is going to do is change anything negative to positive. So notice as this increases, all these numbers adjust. Let's make that our new width. So notice this is now pretty cool. Look at this form change. This would be very hard to model manually and much harder to, say, adjust manually. So if you're a designer and you have an idea of something, if you can model it parametrically, you can then experiment and test a variety of options in real time. And that's the power of Grasshopper. You have the ability to define different geometry using a combination of code and math in order to generate forms that really would not have been possible to build physically. Certainly not be possible to manipulate in real time manually.